Printed circuit boards, or PCBs, are fundamental to modern electronics. They provide a platform to connect electronic components in a controlled and organized manner. Imagine a city with roads and buildings. PCBs are like the city map, guiding the flow of electricity or cars between components or buildings. This organized structure ensures devices function reliably and efficiently. From smartphones to spacecraft, PCBs are essential for almost every electronic device. Understanding the basics of PCB design opens a world of possibilities for creating your own electronic gadgets and projects. PCBs consist of several layers. The top and bottom layers are typically where components are mounted and soldered. These layers are connected by conductive pathways called traces, etched onto the inner layers. These traces act like wires, carrying electrical signals between components. Designing a PCB involves carefully planning the placement of components and routing these traces. It's a detailed process, but incredibly rewarding once you see your design come to life. Learning PCB design empowers you to bring your electronic ideas to life. It allows you to move beyond pre-built modules and create custom circuits tailored to your specific needs. This skill is invaluable for hobbyists, students, and professionals alike. The journey begins with understanding the basics and then progressively mastering more advanced concepts. Before diving into PCB design, you'll need the right software. Several excellent options cater to different skill levels and budgets. Altium Designer is a professional-grade tool known for its advanced features and comprehensive capabilities. It's a powerful option for complex designs, but can be expensive for hobbyists. Eagle is another popular choice, offering a balance of user-friendliness and robust features. It's suitable for both beginners and experienced designers. Eagle provides a free version with limitations, making it a great starting point. The paid versions offer more features and flexibility for larger designs. For those seeking a completely free and open-source solution, KiCad is an excellent choice. It provides all the necessary tools for schematic capture and PCB layout. KiCad has gained significant popularity in recent years, with a growing community and active development. The best software for you depends on your specific needs and budget. Experiment with different options to find the one that best fits your workflow and project requirements. Each software has its own learning curve, so be patient and take your time exploring the various features and tools. Layout and routing are at the heart of PCB design. They involve arranging components and connecting them with traces to create a functional circuit. Component placement is crucial. It impacts signal integrity, thermal management, and the overall manufacturability of the board. Start by grouping components with related functions together. This minimizes trace length and reduces the potential for signal interference. Consider the physical size of components and their heat dissipation requirements. Larger components, or those that generate heat, might need extra space for ventilation or heat sinking. Routing involves connecting component pins with traces on different layers of the PCB. The goal is to create the shortest, most direct paths for signals to travel. This ensures efficient current flow and minimizes the risk of electromagnetic interference. Modern PCB design software offers auto-routing features that can assist with this process. However, manual routing often yields better results, especially for complex designs or high-speed signals. Understanding different routing strategies, such as grid routing, contour routing, and trace impedance control, is essential for creating reliable and high-performance PCBs.